So, good morning, students. Today we are starting the Simplex method, particularly in maximization of the problem. So, we know the problem in LPP. That means the linear programming problems are be given in a format of like this. Here in the problem, solve the following LPP by Simplex method. We are having the so many of methods to solve the LPP problems. So LPP problems are to be solved by Simplex method, Graphical method, BDM method, two-phase Simplex. So these are the four different varieties are to be solved for the problems of LPP. But in the given problem, if you are having the terms of the problem is the maximization z is equals to 3x1 plus 2x2 plus 5x. This is called an objective function. Objective function. And what about these three called constants or conditions? So we will call it as a constraints or the conditions or restrictions. So here we have to solve the problem that will give the objective function of maximization. What is the maximization means? We have to maximize the profit, maximize the profit and minimize the loss. Okay. Or indirectly we can say that higher profit means the loss is minimum, or otherwise the profit is maximum, or otherwise the cost of an item is also less. So the cost is also the minimum. Otherwise we will call it as a profit is maximum. Maximizing the profit is equals to minimizing the cost or minimizing the loss. Here now we have to consider for the given problem, that is maximization is equals to z is equals to 3x1 plus 2x2 plus 5x3, and at the same time the constraints are called subjected to, the conditions is subjected to the constraints x1 plus 2x2 plus 3x3, but x1 plus 2x2 plus x3 is less than or equal to 430. So this is one of the condition, and at the same time one more condition as 3x1 plus 2x3 less than or equal to 460, and at the same time x1 plus 4x2 is less than or equal to 420. So these are the three constraints. So write down the problem. Maximization z is equals to 3x1 plus 2x2 plus 5x3, and subjected to the constraints x1 plus 2x2 plus x3 less than or equal to 430, 3x1 plus 2x3 less than or equal to 460, x1 plus 4x2 less than or equal to 420. This is the straightaway problem they are giving in the question. Then coming to next, the solving the problem by simplex method. So we have to be careful the method of solving. Okay, by simplex method. Simplex method, if in the question itself they mention the method of solving, that is simplex method, means we can directly solve the method by simplex method, or otherwise if you see the constraints, so subjected to constraints, if these are less than or equal, see here here the less than or equal means straight away we have to go for the method called simplex. It is only the possible condition of solving or otherwise graphical method. So simply a less than or equal, only the condition is less than or equal, less than or equal, less than or equal. So that is only possibility by simplex method. So coming to the solving, how to solve? So firstly, we have to convert the equation into, that means convert the objective function into standardized form. What does it mean by standardized form? Standardized form means we have to equate the equations. We are equating the equations. In the question, what the conditions have given? X1 plus 2x2. What are the conditions we are here? That is, so by converting this problem into standardized form. Standardized form means firstly we have to notate the objective function. Objective function is maximize z is equals to 3x1 plus 2x2 plus 5x3. So the corresponding objective function related to constraint. What are the constraints? Subjected to. So we have to convert the objective function to standardized form. Before standardizing the objective function, this is called objective function. These are called constraints. So remember that constraint. Okay, subjected to x1 plus 2x2 plus x3. Previously, these are less than or equal to. Previously, it is less than or equal to 430. So, in the standardization, we are converting these less than or equal to equal to. So, equating these to what? Standardized form. So, we have to convert this as equal to. So, how we are equating? This term is less than 430 actually. So we have to equate means we have to add something or something, we will call it as a surplus slack variables. So if you consider x1 plus 2x2 plus x3 value, it may be 400. Let us consider, for example, if the value is x1 plus x2 x2 plus x3 as 400. So the 400 is less than or equal to 430. Okay, now we are equating these by adding something value called slack variable to 430. So it is less than 430 previously. Now we are equating that to 430. So by adding slack variable. Then again coming to the second one, 3x1 plus 2x3 is less than or equal to 460. So we are equating means we are adding one more slack variable. So this will be the same. So we are adding one more slack variable, that is s2. And the third equation is 4x1 4x2 plus x1 plus 4x2 plus slack variable is equal to 420. So these are the three standardized form constrained equations. Now, based on the constrained equations, we have to write up the objective function. How we are writing? So, actually, for the given problem, the objective function is this, and the constraints are this. But here, we have converted the constraints to equalities. So, once again, we need to change the objective function also with respect to these constraints. So how we are converting without changing the previous one or without changing the quotient. So if you add the same slack variables 0s1 plus 0s2 plus 0s3. Now the objective function has coming to the standardized form as by introducing what slack variables. What are the slack variables we have occurred during the constrained equations? So these are all things we need to represent here. But if you add 0, multiplication of 0 with s1, there is no changing in the value of the objective function. So 0s1 means 0, 0, 0. With that, what is the objective function? It has come to the standardized form. Even though it has come to the standardized form, there is no change in the original objective function. So like that we have to make up the problem. Again, next x1 comma x2 comma x3 s1 comma s2 comma s3 greater than or equal to 0. These are the variables always be greater than or equal to 0. That we need to specify it in the every session. So we have converted the problem into standardized form.
సార్
Next.
సార్
చెప్పండి.
స్క్రీన్ చేంజ్ అవ్వట్లేదు సార్, అదే రాసేది కనిపించలేదు.
So in the maximization problem, we need to make the standardized form. So standardized form is by including the slack variables. These slack variables are occurred from these constraints. So then making the step 1. After that, we have to go for the step 1. What is the step 1 means? By entering the slack variables, we have taken up the standardized form. So write the standardized form in a clear manner such that it is very clear to framing the problem in the table. So that, what is the table? So there is a condition is that when the optimality solution will be occurred for the given problem means if Zj minus Cj is greater than or equal to 0. See here, the condition is Zj minus Cj is greater than or equal to 0, then only the solution is optimal. Otherwise, we have to follow some procedure by entering and leaving the variable and calculating the key element and the ratio values. So we have to do the procedure until Zj minus Cj greater than or equal to 0. So either maybe the greater than 0, that means, or 1 2 3 more than 0, 0 1 2 3, otherwise equal to 0. If Zj minus Cj are all the values of these are 0, then the solution is optimal, or otherwise if they are greater than 0, then also the solution is optimal. Until that condition we have to solve the problem. So we can't find where we are getting these things. So try to solve the until the solution gets optimal. So based on the standardized form, we have to make a table. So please write down the table in a clear manner. That is, it is a syntax. So always the problem is follows the same table whenever it is of simplex method or begin method or through phase simplex method. Whatever the method we are following, it follows the same syntax of the table. So clearly write it down the table. One is first one, CB basic variable xj, that means x1, x2, x3, s1, s2, s3. Solution, simply we will call it as the xb. This is called the basic table. Then again, after that, over the table cj. So in the table the values are constant. cb is always constant, basic variable this is also constant, cj is always be constant. But here the what are the function we are having here, that is based on the standardized form. What is the standardized form? We are getting here 3x1, x2, x3, s1, s2, s3. So this is based on the standardized form. We have to note the variables. Here the variables is x1, x2, x3, s1, s2, s3. So like that we have to frame the variables. So here basic variables means x1, x2, x3, s1, s2, s3. The C means coefficients. So the coefficients of these. So here, what are the coefficients in the objective function? What are the coefficients? 3 for x1, 3 for x1, 2 x2, 5 x3, 0, 0, 0. If you remember these, 3x1 plus 2x2 plus 5x3. See the objective function 3x1 plus 2x2 plus 5x3. At the same time, the constraints also representing here. The constraints. What are the constraints? 1, 2, 1, 1, 0, 0. Again 3, 0, 2, 0, 1, 0. 1, 4, see 1x1, 2x2, 1x3. 1x1, 2x2, 1x3 plus s1 plus 1s1. S1 or 1s1 both are same. Then what are the equations? 4 430, 460, 420. Then again, what are the basic variables? So we have noted that basic variables as x1, x2, x3, s1, s2, s3. So among these six, we have to give the higher priority to s1, s2, s3. If they are not available, s1, s2, s3, we have to go for the x1, x2, x3. So firstly, we have to give the preference to s1, s2, s3. What are the coefficients of these variables? CV means coefficients of basic variables. What are the coefficients of s1, s2, s3? That is 0. Then formula for Zj equal to CB into Xj. CB into Xj. CB means 0, or what are the values here, and Xj means the corresponding these values. So multiply with this 0 into 1 plus, so here it is sigma of formula is J. Zj is equals to sigma of Cb into Xj. Xj means x1, x2, x3, whatever it is. So here the condition is equal to sigma of 0 into 1 plus 0 into 3 plus 0 into 1. What are the values? 0. Always the values is, all the values is 0. What are the solution we are getting here also? The solution is 0. So after that, finally we have to calculate Zj minus Cj. So finally we have to get it the Zj minus Cj. Zj means 0, Cj means the correspondingly 3. So 0 minus 3 as minus 3, 0, 2, minus 0, minus 2, that is minus 2, minus 5, 0, 0. So what are the values getting here? Zj minus Cj is always be what? Greater than 0. But here the 0 is available, but 0, 0, 0. Under S1, S2, S3, it was satisfied. But whatever the x1, x2, x3, it was not satisfied. That is, Zj minus Cj is less than 0. So this is the condition as not an optimum. So what we have to do is, by making the condition called ratio. So how the ratio will be means, what is the most negative value? So what is the thing we need to find out is, we have to follow the minimum of the thing. So at least one negative is there means we have to go for the same procedure. All the values of Zj minus Cj is to be greater than or equal to 0. Any one of the case or any one of the variable is having negative, so we have to eliminate that negative. So here we are having three negatives. Among the three, which one is to be identified for deletion? So we have to consider what most negative. So in the negative, what is the highest value? Okay, prefixing of negative, what is the highest value? So minus 3, minus 2, minus 5. What is the highest negative value means deciding of the negative sign, which one is the highest numerical value. So highest actually 0, minus 1, minus 2. Minus 1 is the highest actually. Minus 2 is the least when compared with the minus 1. But what we are considering is most negative means deciding the negative symbol, which one is the highest numerical value. So here this is to be leading. Okay, so after that, by taking the symbol as arrow mark and round out these column, round of these column, and at the same time this column is called key column. So this is called a key column, and at the same time finding this ratio. The ratio means xb by key column, xb by key column. What is the key column here? 1 to 0. And next, what is the xb? xb means 430 by 1 equal to 430. Next, 460 by 2, 230. Next, 420 by 0. So we can eliminate this since it is a infinity. So this is not to be required. Then again here we need to round up the, here most negative means oppositely least positive. So we have to write it least positive. So based on the problem, here what we are reading, what we have cleared about that, this is leaving, and so like that we have to mark the particular row. So while making the column, we have to note the value as most negative, and for row least positive. 430 is more than 230. At the same time, this value is more than these two values. So which one is the least positive and most negative? Then coming to the session, the next step is we have to write it the values. X3 is entering and S2 is leaving. So that we have to mention it clearly. X3 is entering and S2 is leaving. So while X3 is entering and S2 is leaving, what are the next values? So here we need to take one more value, that is one more a table is to be required. So x3 is entering and s2 is leaving, so then the table will becomes CB basic variable x1, x2, x3, s1, s2, x3. This is called solution. X3 means solution. What are the values of here? So in the here, which one is leaving? S2 is leaving. S3, x3 is entered. So S2 is leaving, x3 is entering. So what in the table, what are the basic variables? S1, S2, S3. In the actual case, S1, X3, S3. So what are these values? According to the previous condition, some of the elements were eliminated. After that, the new table will becomes what? S2, S1, X3. So S2 already leave. So in the place of S2, which one is entering means X3 was entered. So S1, X3, S3. Then what are the basic variables here? That is Cj. Portions of this. The same values only. 3, 2, 5, 0, 0, 0. And then X1. For these S1, what are the basic variable? 0. For X3, it is 5. S3, it is 0. The same basic one. After that, next, Zj equal to sigma of Cb into X. So, here, what are the values of new table? That is, for X1, so it is a simple technique we will follow here. A simple technique which is very easier to identify the table. So here, if you see, firstly, we have to follow the condition as, whichever the key variable or whichever the new element entered into the table. What is the thing? S2 already leave. Which one was entered? X3 was entered. So new X3 means, so this is a formulas we have to remember. New, that is newly X2. The new X3 is old S1, sorry, S2. Since the old S1 means the X3 is replaced with X2, sorry, S2 is replaced with X3. So the new X3 will be old S2 by key element. What is called the key element? Where the row and the column are intersected. Where key row, key column and key row are intersected. This is called the key element. So divide these entire, which one is the leaving? So entire these row with the key element. So after getting these, what is the values we are getting here means new x3 equal to old is 3, 0, 2, 0, 1, 0. The solution is 460. So all the values by key element is 2. So what are the values here? 3 by 2, 0, 1, 0, 1 by 2, 0, 230. This is the new table we are achieving here. So A simple technique we will follow here it is, see here, what are the values of S1, S2, S3? S1, S2, S3 will form a identity matrix. Identity matrix means 1, 0, 0, 0, 1, 0, 0, 0. The same thing, simply you just write it in the next table also. But what are the condition is S1, S2, S3 are the values of identity matrix. So write it the same thing. S1 is 100, S3 is 001. So S1 is 100, S3 is 001. Then what about the next one? S2 is 010. Actually S2 is 010, but S2 is already left the table. Which one is entered? X3 was entered. So the values of 010, which is belongs to S2, is to be write it in the place of X3. X3. That is 010. See here. S1 is 100. S2 is replaced with X3. So the values of S2 is replaced to 010 and S3 as 001. With that, almostly only the left thing is X1, X2, S2. These three are to be required. So by entering these, next framing the table for these values. So what are the tables values here? What are the tables we are having? The new S1, new S1 and new S3. So why means the X3 S2 was replaced with X3 so that the table will also becomes the new one. So for the new one table, S1 will also called a new values and S3 also will be having a new value. So for new S1, for new S1, we have to do the thing is multiply. See here X2 it was already the new one. So multiply with these values. So here note it down X2. If you are having the new value of S3 here, we have to simply do a cross multiplication. Or otherwise, simply here what is the condition is among S3, see here among S3 we have to get it the values as 010 already over, 100 over and 001 is to be required. So for S3, while catching up the equation as 001, so the last element is already a 1, we have to substitute what are the same values in the first iteration, that is S3 as 140001. The same thing we can write it here. 1, 4, 0, 0, 1. And at the same time, what are the values? Here it is 420. Since we have not changed the S3, since the values of the S3 we are already having a numerical value of 1. So it follows a simply identity matrix. So we are creating the nothing, or we are creating the no disturbance in the S3 column. So the same column we have entered S3 as 140001 and 420. That is the equation of solution also the same 140001. It is 420. Then only the final thing is S1. So for creating the S1, what are the basic variable, or what is the key element we are having? That is minus 1 by 2, and this is 2 minus 1 by 2, and which is 200. So here also the condition is Zj is equals to Cb into Xb. So 0 plus 5 into 3 by 2, that is 15 by 2. This is 15 by 2, and again this is 0, 5, 0, 5 by 2, and it is also a 0. And Zj minus Cj as Zj minus Cj, that means 15 by 2, 15 by 2 minus 3. That means 15 by 2 minus 3, 6. That is 9 by 2, and this is minus 2, 0, 0, 5 by 2, and this is 0. So here also only the negative is minus 2. So and at the same time it is also the most negative value. Only one is there. So writing this as a key column, and for these key column values, note the ratio. Ratio means XP by key column. So 200 by 2 is 100. This is infinity. So again the condition as most negative and least positive. Least positive means we have to eliminate S1 is leaving and X2 is entering. So for the table 3, again the same condition. CB basic variable x1, x2, x3, s1, s2, s3 solution, that is simply what are the basic variables? Newly basic variable as s1 is leaving, x2 is entering, x2 previously x3 and s3. So here only the replacement with s1 is replaced with x2. So x2, x3, s3. Then coefficients 3 Cj value 2 and 5 0 0. So the coefficients of x2 is 2, coefficients 5, x3 is. Then what are the same? Here the identity matrix has x3 as 0 1 0, s1 as 1 0 0, s3 as 0 0 1. So x3 is same, s1 is replaced with x2. So the s1 is to be entered into these conditions. So or otherwise x3 as by defaultly 0 0 1, s1 as 1 0 0, s1 as 1 0 0. It was leave. So x2 as 1 0 0, x3 as 0 1. Again, what is the same? After that, which one is the leaving or newly entered? This is the newly entered. Where it is the key column and key row is key element as 2. Then key element as 2. Divide the key element in the newly entered thing. Newly entered thing is x2. So x2 is replaced with the new values. New values is -1, 2, 2, -1 by 2 by 2. So -1 by 4, 2 by 2, 1, 0 by 2, 0, 1 by 2, -1 by 4. -1 by 4, 2 by 2, 0, 0, -1 by 1 by. Then solution is also changed to 100. Then again x3. New x3 is having the x3 as 0, x3 as 0 1, but defaultly x3 as 1. So write the same thing in the next column also, x3 as 1. So 3 by 2, 0 1, 0 1 by 2, that is 0. After that, that is infinity. See, it is infinity. So x3 was 1. Next, whatever the s3, s3 only the differences. S3 means here in the S3, what are the value we are facing here? 4. But in the S3, in the x2 column, see here, in the x2 column, we have to get it 1 0 0. So when the 4 will be 0, when the 4 will be 0 means, so this value is required to be 0. So what is the actual thing we are having? 4. So new S3 equal to old S3, that is 4 minus, we have to use the new thing. New means minus, it is to be 0. So 4 into new x2. So old S3 is 4 minus multiplication of 4 into new x3 is correspondingly new x3 is 1. So by multiplying with 1, 4 minus 4 equal to 0. So we have to follow the equation as this. Old S3. So for all the values, what are the values we are facing here? 1 4 triple 0 1 420. 1 4 triple 0 1 420. So for that, 1 4 triple 0 1 420. For all these, we have to do the same operation. So one is old is 1 minus 4 into 4. New element is what? The corresponding row. It is minus 1 by equal to, at the same time, 4 minus 4 into 1. At the same time, 0 1 by 2. That is 0 minus 0 into 4 minus 4 into 1 by 0, 4 into minus 1 by 1 minus 4 into 1. 420 minus 4 into. So for these values, okay, minus into minus plus, 4 gets cancelled. That means 1 plus 1 equal to 2. 4 minus 4 is 0. That means the same values. Write it here. 2. Next 0, which is already there. So 0 minus 4. 0 minus 0 into 4. That is again also 0. 0. 0 minus 4 twos minus 2. So here the value is minus 2. Minus into minus plus, 4 gets cancelled, that is 1. So it is 1. 1 minus 4, that is minus 3. So here no need to calculate these also. That is S3. So simply we just remember what are the values we need to find out. So by framing this in identity matrix is enough. So rest of the values you don't need to be touched on. Then what is the finally? This value is not to be required. So what is the S3 value? S3 value means 420 minus 400. That is again ZJ is equals to CD into X. So Actually, find it out the values of multiplication. Multiplication be 2 into minus 1 by 4 plus 5 into 3 by 2 1 0 2 2 0 minus 1 by 2 plus 15 by 2. So 14 by 2, that is then this is 2 and this is 5 0 0 0, that is 1 minus 1 by 2 minus 1 by 2 plus 5 by 2. What is it? 4 by 0 0. The solution is 200. Zj minus Cj. Zj minus Cj, 7 minus 3, that is 4. 2 minus 2, 0. 5 minus 1, 0. Zj. 1 minus 0, 1. 2. So after this, what are the values we are getting? 4 0 0 1 2 0. So Zj minus Cj, all values are equal to 0 0 0 0 and greater than 0. So the condition of these has the solution with see here, the solution is with coefficients as x2 is 2, x3 is 5. So we have to write it, the solution is the solution is x2 is equals to solution 100, x3 equal to unity, that is not required, s3 equal to 20. But s3 is not always to be required, so only the value is by substituting this in the whatever the x1 is not to be found, so it is also negligible or taking the values as 0. So what is the objective function? Now we have to write it the objective function. Now what is the objective function? Z is equals to 3x1 plus 2x2 plus 5x. But what is the value of x1? We have noted as no value of x1, so it is simply negligible, 0. At the same time, x2 is 100, so 3 into 0 plus 2 into 100 plus 5 into what is the x3? What is the value of x3? Here also x3 has no value. No value means that is simply a 0. So by substituting, z is maximum value of z is 0. So maximum value is 200. So this is the value of condition. So finally maximize z is equals to 200. This is the final solution. So after getting this solution, the optimality function was obtained. So when the condition is reaches to Zj minus Cj is greater than 0, then the solution is optimal. So we need to go for the ratio also. Previously we have calculated the ratio. So only the thing, when the ratio will be there means whenever the Zj minus Cj values are negative, then only we have to go for the ratio value. These ratio value will decide which one is the variable leaving the table. So after that, by leaving the variable, and which one is to be replaced with the leaving variable or entering variable. So that is the problems we are having. So like that, we have to go for the next method of graphical method. So the same problem we can solve it through graphical method also.